Hello everyone. In this video, I want to provide an overview of APIs or application programming interfaces. We're going to talk about them generally, and then we're going to talk about them more specifically in terms of web APIs. So for data science, why is learning APIs important? Well, typically for our data science applications, we have inputs to our applications that are data, right? And this data usually takes two forms. It's either static or it's dynamic. And when I talk about static data, I'm talking about data that doesn't change. So for example, a file that sits on your hard drive and no other program updates the contents of this file. Like, for example, say a CSV file. You might have exported some data maybe from a survey in CSV form, and it sits on your machine. And even if someone else goes and fills out your survey, since you've already downloaded the data and it's statically sitting in a CSV file on your machine, it's not dynamically being updated for that new survey response that might have just come in. A few other examples of static data would be, say, Excel files, text files, SQL data dumps. Anytime you have data that doesn't get updated, it's static, and it can quickly become stale or out of date if perhaps it's sampled from a phenomenon that continues after the data has been pulled. On the other hand, dynamic data is always up to date. So for example, say a database that's actively being written to perhaps every time someone does a bank transaction, or perhaps every time someone fills out a survey. Another example would be data that comes from, say, a web API. Okay, so this would be an interface for programmers like us in order to get access to data that is updated by another entity, like a company, say a big one like Google or Facebook or Twitter. So these are just some examples of static versus dynamic data. We're going to talk generally about APIs and then more specifically about web APIs. And the reason why is typically your data science applications need to use dynamic data. They need to query data from, say, the web or from a database because they need to work with the most up-to-date data. All right, so let's start generally with a definition for API. So API stands for Application Programming Interface. And the definition that I like to use to introduce APIs is functions for programmers to use without needing to know the implementation details. For example, let's say you're using a library like scikit-learn, which is a really popular data science and machine learning library for Python. You don't need to know how, say, a decision tree is implemented in order to use a decision tree classifier from scikit-learn, right? You read the documentation, you see what is the contract for using a decision tree classifier. What are the inputs, what are the outputs, and what are the assumptions, right? Scikit-learn is an example of an API, right? It provides an interface for programmers to use all of the library classes and functions and units without having to know the details of how they're implemented. So now let's zoom in a little bit and talk specifically about a web API, which is going to be the focus of this video today. So a web API is essentially an API that's on the web, but I'll give you a little more specific definition for it. So a web API is a set of endpoints, which you can think about like functions. A website provides for programmers to use, and I'm going to put in parentheses, to get data from / post data to. For data science, you're typically just getting data from a web API because you want to use that data for your own purposes, your own data science and data mining purposes. But APIs also allow you to essentially push your own data up to that server that's hosting the API. All right, so let's draw a little picture here to help explain an API. And then, as you can see at the bottom of my screen here, I've got a URL, which is an example API request, and I want to break down the different parts of it to help you understand the details of how to start working with APIs. So I'm going to scroll over here and draw a picture to represent this web API definition in a little bit more detail. So first, let's say we've got a client and we've got a server, okay? So the client could be you. Here you are, okay? You're a programmer. Or it could be a program itself. So for example, let's say you want to use an API as a programmer, then you probably, if you're working with Python, have an interactive Python session open, and you're using a library, or maybe you're just using a terminal with the curl command, and you're making requests to a server. If you have a program, then this could be, all right, e.g. a Python script. You're not in interactive mode. You've written a Python script, and perhaps you run it whenever you want to fetch updated data, or maybe you've scheduled this Python script as part of maybe a cron job to run, say, every night at midnight to get updated data in order to process and produce maybe new predictions for something. All right, so there's just some examples of clients, programs or programmers who are interested in getting some data from a server. Okay, so first, they need to go read the documentation, right? In front of this server is an API, and you have to read its documentation before you can use it. Okay, so let's say I want to get some data from Google Maps or Google Places. Okay, so I know that Google has servers out there that host APIs that I, as a client, can read the docs about and see how I can use the API to get data from the server. So that's the first step you do. You try to find the documentation for the API that you want to use to get data from. That's going to tell you the contract that you as a programmer have to adhere to in order to get data from the server. All right, so once you do that, then you're going to formulate what's called a request. And I'm going to write in parentheses here, GET, get request. Okay, there are different types of requests. If you want to get a resource or get data, then you make what's called an HTTP, which is the protocol, an HTTP GET request. So this request is going to go to the API. The API runs on a server that is going to route this request to the appropriate function. Okay, the server is going to validate the request. Okay, so for example, if this is an authenticated API, then that means the client has to identify themselves and provide the appropriate credential for the server to say, okay, you are who you say you are, and you do have authorization to this endpoint, right? Wherever you're trying to make the request to. Great, I'm going to give you your data. It's also going to make sure that your request is well formed. Okay, you can't just send garbage up. You'll get what's called a bad request response. You've got to, like I said, read the docs. You've got to format your GET request properly. And if you do that, the server will validate it and say, yep, perfect, I can handle this. So then they're going to handle the request, right? So they're going to fetch the data that you want. And the server is going to package up the data as what's called a response. So I'll kind of expand this picture a little bit here. The server might have to make some requests to a database, perhaps make a query, get the data back, restructure it into a response, and then send the response back, typically what's known as in the format of JSON. Typically, your responses back from a server are going to be JSON, XML, or HTML. The example that we're going to do is going to receive a JSON response, which is probably the most common type of response that you're going to get back for data science applications where you make a GET request to an API in order to get a resource or get some data back. All right, so this is kind of the big picture. Now let's zoom in on the GET request and the JSON response. I'm going to start with the JSON response because this is going to be pretty short. JSON is short for JavaScript Object Notation, and it's really just a dictionary. And what is a dictionary? It's a collection of key value pairs. If you're familiar with Python, which is the programming language that this set of videos uses, then you probably worked with dictionaries before. So dictionaries really are the form key, colon, value in curly brackets. So once we get our response back from the server in our Python code, then we're simply going to convert the response into a Python dictionary. And from there, we'll know what to do, right? We identify what is the value we're trying to get out, and then we'll use kind of a bottom-up approach in order to figure out, well, what is this value's key? Okay, if this is nested, this key is the value of what key? And we'll just work our way all the way back out to the root JSON object, the root dictionary, and we'll figure out how to parse from there. All right, how about the GET request? All right, so the GET request is really a URL. Okay, we're familiar with working with URLs. Every time we go to, say, google.com, right? We go to the URL bar, we type in google.com or any address, right? If we make, say, search on google.com, we get an updated URL. You can go take a look at it, see, the different query parameters and the path, the protocol, etc. Okay, take some time and start familiarizing yourself with URLs. We use them all the time, and there's a lot of data, a lot of interesting information packed into them. All right, so a GET request is really a URL. Okay, we're going to break down an example GET request via URL here shortly, but I don't want to oversimplify this. So it's really a URL plus some headers and plus a body. Okay, so a GET request doesn't have a body. Okay, but other types of requests like post requests, they can have bodies. Depending on the API, you may or may not have to touch the headers or touch the body, but I just want to put them in here. I'll put them in parentheses because I don't want to oversimplify requests. But for us, just getting started with the demo I've got prepared for you, we're going to do a simple GET request. We're not going to have to worry about headers or the body. It's going to be a simple GET request. We'll just take a look at the URL. All right, so I'm going to just make an arrow way over here. Oops. Kind of missed the target here. And here is an example GET request URL. So Apple maintains iTunes API where you can search their database for different objects. These could be movies or music or artists or songs or podcasts. Really the whole iTunes database can be searched via an endpoint on an API. So this is a valid request to the iTunes search endpoint. You could type this into your URL bar right now, and you would get a valid JSON response back. So what this search does, you can probably read through it and figure out what it does. What it does is it makes a request to search iTunes looking for movies that have the term Thor in them. At the time of this recording, there are five results for Thor movies that this is going to return as part of a JSON object. All right, so before we write Python code in order to see this in action, let's break down each part of this URL in order to better understand how a request is formulated. All right, so let's start at the beginning. So HTTPS, this is what's called the protocol. The protocol essentially defines how the client and the server communicate. There's HTTP and HTTPS. I just want to make a little note here about the S. So this is short for secure, and this means that the communication between the client and the server is going to be secure. It's not going to be passed in plain text. So you often want to try and use APIs that have the HTTPS protocol. That way your conversation with the server is secure. All right, next we have iTunes and apple.com. So apple.com is what's known as the domain, and then itunes.apple.com, this is what's known as the subdomain. So how this works is together the subdomain and the domain are used by a service called DNS, which stands for the Domain Naming Service, in order to route your request as a client, right? When you're, say, going to Google Chrome and type something in the browser, or you're writing a Python script in order to make a request, you specify a URL, and part of that URL has the domain and the subdomain. So DNS is going to take your request and make sure that it gets routed to the correct server. So servers are identified by IP addresses, but we as humans are not very good at memorizing a string of numbers, which is why we use DNS. So iTunes.apple.com is much easier to remember than a string of numbers. So DNS, the Domain Naming Service, is this nice service that's going to take what we have as, iTunes.apple.com and redirect this to an IP address so that the appropriate server can handle this request. Now, that server has likely a bunch of different endpoints that it's listing for. And one of those endpoints is identified as search. So after the domain, apple.com, we have a slash, and this is what's known as the path to an endpoint. Okay, there might be multiple endpoints on the server. The client specifies which one they're making a request to by specifying it as part of the path. So remember, I said earlier that an endpoint is like a function. You can think about this as essentially identifying what function on the server do we want to execute. We don't know the name of the function, but that's what the server is going to look up via this path. All right. After the path, we have a question mark, and this question mark starts what's known as the query string, also known as query arguments or query parameters. After the question mark, like I said, we have the query string. So this whole thing here is the query string. It is essentially an ampersand separated list of key equal value pairs. And this is where we as the client specify the details about our request. So we're making a search here of the iTunes database. So this is where we provide the details of our search. So at a minimum, we should provide the search term, right? Imagine going to a search bar and typing in what you want to look for. Okay, so term here is a key and Thor here is a value. So whatever function is routed to from this path search is going to parse out Thor as the term to search for, and it's also going to parse out movie as the type of media we want to filter by. So like I said, the query string, aka query args, aka query parameters, this is really a chance for the client to specify the details about their search. All right, so like I said, try it out, type this into a URL bar, you'll get a JSON response back. Take a look at it, you'll see what the response looks like and see if you can find out what are the names of all of the movies that have the term Thor in them. The next video is going to take this URL and paste it into a fresh Python script and begin showing you how you could use Python as a client in order to get a response back from a server, and then how to start parsing that JSON response. So like I said, paste this into a URL bar. Essentially, you're using Chrome or your favorite web browser as a client, and then stay tuned if you want to see how you can do this programmatically with Python. Thanks for watching.